On this example, we're given a quadratic function in general form, the expanded out version, and we're going to gather a ton of information about this and put it all together into a nice graph of this function. So the first thing we want to ask is, does it open up or down? We're going to base this on whatever number's out in front here for a. So this is a negative value out here, so it opens down. And that general look is going to have this sort of idea going on. We're going to have a vertex at the very top. And that was because our value out here, a, x squared plus bx plus c, the a was negative. So that told us it opens down. Next up, let's see if we can find the vertex. On almost every single one of these quadratic functions, we're going to be looking for the vertex. So it's really nice to know this formula, negative b over 2a, to get us with our vertex. So in this case, I already identified a, b, and c. b is going to be 1, so we have the negative 1 over 2 times a was negative 1. A little bit of simplifying down here, and we get 1/2. So that's the x value of our vertex. We need the y value to go with this. So to get the y value, or sometimes we use the letter k to represent this, the easiest way is plug this back into the function. So we have an x value, we have a function. Let's go ahead and plug into the function with this x value. So replace each of the x's with that x value. All right, now a little bit of simplifying down. I would probably go ahead and say, well, this is the negative of 1/2 squared. That negative is not inside being squared, so it's 1/2 times 1/2 makes 1/4 plus 1/2 plus 2. To combine these together, I'm going to need to get a common denominator across the board. So I think that common denominator is going to be 4. So I'm going to multiply by 2 over 2, multiplying by 1 strategically in that second fraction. Visualize this as 2 over 1, so I'm going to have to get a 4 in my denominator, so multiply by 4 over 4. So we're at negative 1/4 plus 2/4 plus 8/4. With that common denominator, we can combine our numerators together. I believe we have 9/4. And I get it if you're one of those people that likes decimals, but I'm going with an improper fraction in this case. All right, so now we have our vertex. We can work on getting our standard form. So the standard form or vertex form, how I like to visualize this is you take your original function and you've moved it around. We've moved everything. The vertex has gone from the origin. If it was just an x squared graph, it's gone to the right 1/2. So I'm going to put a 1/2 in with the x. And since it's moved to the right, I'm going to be subtracting 1/2. And then we've moved the vertex up positive 9/4. So I'm going to attach a plus 9/4 to the entire function. So what we have going on here, this is the right, and this is the up transformation. Now, the other thing we have to be very careful about is there could be a stretch or compression happening out in front here, maybe a reflection. This information is the exact same a would go out here as what we have as a in the original. So in our case, we're going to put a negative or negative 1 out in front. Okay, next piece of information we can go ahead and pick is the axis of symmetry. All right, the axis of symmetry is a vertical line that cuts right through the very middle of our parabola. So since it cuts right through the middle, it's going to cut right through the vertex, and vertical lines have all the exact same x values for the points on them. So it's going to have the exact same x value as our vertex over here. So the axis of symmetry is just x equals 1/2. All right, the next piece of information I may gather is the y-intercept. Okay, as we probably know at this point, all y-intercepts have something in common. They have an x value of 0. So to find this, what we can do is we can take our x value of being 0 and we can plug it back into the original function. Or we could plug it into the standard form, either one, but I like the general form on this one. So I can say the negative of 0 squared plus 0 plus 2. Again, plugging into either one of these versions, the different forms, is going to produce the exact same y-intercept. All right, the very last thing we want to do is find the x-intercept. And then we'll put it all together and get a nice graph. All right, very similar to our y-intercept, where x is equal to 0. For our x-intercept, our y value is going to be equal to 0. So to accomplish this and solve for our x-intercepts, if we have any, what I'm going to do is I'm going to use the standard form. I think it's a little bit easier way to go on this. So I'm going to plug in, this is like saying f of x has to be equal to 0 for all of our x-intercepts. So I'm going to put 0 in on the left-hand side of the standard form up above, equals negative of x minus 1/2 quantity squared plus 9/4. Now you may be saying, it'd be easier if I just use the general form and maybe the quadratic formula, but walk with me through the steps here. As we're trying to solve this down, I'm going to try to make this into a power equation, meaning isolate whatever is raised to the power on one side by itself. To accomplish that, I'm going to move the 9/4 to the other side, so subtract 9/4. We're almost there, except for this negative out in front. That's not underneath here as part of the base with the exponent attached to it. So let's get rid of that negative. We can either multiply both sides by -1 or divide both sides by a -1, and it accomplishes the same thing. So I'm going to get my negatives, two negatives multiply together to make a positive. Over on the left-hand side, I've got two negatives, again, make it positive. Now we have a power equation. One side's all raised to an exponent, constant on the other side. So let's go ahead and try to get rid of our square by applying a square root to both sides. As we do this, because we applied a square root to both sides, I'm going to try to remember a plus and minus case. All right, so this is going to be positive or negative. And then reducing down here, this is why I left it as an improper fraction. We can take the square root of the numerator over the square root of the denominator. Equals the square and the square root are inverse operations. They get to cancel on the right-hand side, so we're left with x minus 1/2. So really, remember we have two cases here. We have a negative 3/2 equals x minus 1/2, and then we have a positive 3/2 equals x minus 1/2. To solve for x in these individual cases, we're going to add 1/2 to both sides. In both cases, we just have to be careful that this is going to give us x equals negative 3/2 plus 1/2 is negative 2/2 or -1. Over here, we're going to go ahead and add 1/2 to both sides. But this time we have positive 3/2 plus another 1/2 makes positive 4/2, which is equal to 2. So now we have two separate x-intercepts that we can put on the x-axis. All right, now that we've collected all that information, let's try to put it all together and get a pretty nice graph going on here. All right, so the vertex is going to be at 1/2, 9/4. Well, 1/2 shouldn't be too tough to identify, but 9/4, if we put that as a decimal, would be maybe a little bit easier to plot here. 2.25 is equivalent to 9/4. So that's our vertex on here. Next up, let's go ahead and put our y-intercept we found was going to be at 2. Our x-intercepts were at -1 and positive 2. And our axis of symmetry, which isn't actually going to be part of the graph, but we'll go ahead and plot it, because sometimes that helps in graphing this, is this vertical line, and we identify it using a dashed line usually, going vertically at x equals 1/2. The last thing we need to do is go ahead and connect the dots, get a pretty nice graph going on. If we identified additional points, we could get an even better graph, but this is a pretty good one. It should look like a mirror image to the left and right of this vertical line, our axis of symmetry. All right, so hopefully this helps out as you're trying to collect a ton of information about a given function, and they get a really nice graph going on for this as well. All right, good luck. Hope this helps.